Record on this thing. All right.
Yeah, okay. So most of these are word problems. But
Okay.
it says the average income at a fruit stand is $12 times the number of customers, N, minus $75, all divided by N. It says use a graph of the average income to estimate the number of customers that makes the average income $8 per customer.
All right, so make sure I got this right. The average income is $12 times the number of customers minus 75 all over N, or minus
That
5 over
all over
separate fraction?
all over N.
Just like I've written it?
Yes.
Okay. And they want to know how many customers it's going to take to make the average income 8, right?
Yes.
So this is the equation I have to solve. Now, note that whenever you have an equation that only has one variable, you're going to be able to solve it.
Right.
Okay, so let's solve it. The first,
So we'll both sides by N.
okay.
And then subtract 12 from both sides, or 12N. And then divide by -4.
Okay, and that's a non-integer value. It is 19 and a quarter, I believe. Is that, or is it 18 and a quarter? Let's see, 4 goes into that. Once 35, it's 18
3/4.
and 3/4. So, what is the answer to their question? In fact, you might want to reread the problem to me, because it depends on how they kind of stated it.
Okay.
The last sentence. What's the last sentence say?
Use a graph of the average income to estimate the number of customers that makes the average income $8 per customer.
All right. We didn't graph this. I assume that that's this a calculator question?
Yes, I believe so.
Okay. So had we graphed this, when n is, I'm trying to figure out what this graph would look like. Wow, in other words, n's going to have to be at least 6 to even be profitable. N's got to be greater than 7. So we don't even get a, in other words, if this is the average, I as a function of n, and this is n, am I correct?
Yes.
Okay. If you wanted to graph this, how would you, what kind of calculator do you have, William?
I have an N-Spire, but I could not find it, so I'm using my TI-84.
Okay, that's fine. How would you graph this on your TI-84?
Would I use the original equation then, like the 12n minus 75 all over n?
Here's the thing. Your TI-84 requires everything in terms of y and x.
Right.
Okay? So if you go to your graphing part where you can put in various y's, y sub 1, y sub 2, so forth,
Mm-hmm.
well, the only thing you need to put in is this one. Go ahead and do that. In other words, I solved this algebraically because I didn't hear the question fully. But if we do exactly as they suggest, let's go ahead and graph it. I think you can do that. I don't need to pull it up on my screen. I could using Wolfram Alpha.
That's okay. I've got it right here.
Okay. And now what you're looking for is where on the curve is that 8? And your curve, as I said, you don't even get a positive, you get negative ends. The curve goes something like that, I suppose. And so
Yeah.
that point there, is that close to what the curve does?
Yes. Yeah.
Interesting. So we figured out that that was 18 3/4 when, in other words, the coordinates on that point are 18 3/4, comma 8. So I guess the answer to their question is 19.
Okay.
Since they said approximate it from the graph. The key thing here, and if you want an exact answer, another way to do this, and in fact this isn't a bad way, is make that y sub 1 and make y sub 2 equal to 8.
Okay.
And then it's going to graph two lines. It's going to graph y equals 8, and it's going to graph the original function, and then you can just request the intersection to figure out what the coordinates on that point are.
Okay.
But this is a useful technique. I'm sorry I didn't do it the first time, because it's one I always kind of forget too. In other words, if you want to solve a difficult equation, let's say, I know you haven't had trig yet, but let's say I had an equation like that, and I did not know how to solve it algebraically. And in fact, I do not know how to solve this algebraically. See what I've written at the bottom? X sine x equals 5.
Yes.
That means x times the sine of x equals 5. Well, what number must x be? Well, that's not easy to solve. But if I went into my calculator and I made y sub 1 x sine x, and I make y sub 2, even that won't help that much. But if I make y sub 2 equal to 5, now I'll end up with a curve intersecting a horizontal line. And I can find all of the solutions. There might be more than one or two. But so this technique here works really good when you have equations that can't be solved algebraically.
Okay.
Okay? And I'm guessing that's what she probably wanted you to do. Is your teacher a male or a female?
Female.
Okay. I keep calling her she. I wasn't sure whether it's a she or not. But yeah, this is the way you want to do it.
Okay.
Okay. And of course, algebraically is always better. In other words, if the question was, how many does it take to average $8, then I think the answer would be 19. Because 18, you can't have a partial number of people. So you have to have 18 or 19, and 18 would not average $8. It would average a little bit less than 8. So if you needed to average exactly 8, then the answer's got to be 19.
Okay.
That's probably why they posed it as a question, do in your calculator and approximate it.
All right.
All right, what else you got?
So another word problem says an internet service provider charges a $50 installation fee and a monthly fee of $43. Write a graph Oh, write and graph an equation that gives the average cost per month as a function of the number of months of service.
Okay.
And then after how many months will the average cost be $53?
Okay. So let's figure out, we can't graph the equation until we can figure out the function, right?
Yes.
So let's figure out the average cost. Whenever you're doing a word problem, probably the most important first step is to define your variable. And you can get the answer to that question usually by just reading the last sentence. What's the last sentence say?
After how many months will the average cost be $53?
What's my variable?
No, the average cost.
No.
The number of months.
There you go. In other words, that's what it's asking for, right? It doesn't ask for average cost. It asks for how many months of service. Now, let's put in a function defining average cost as a function of x. What's it going to be? Now, sometimes it's useful on these because it's not that easy to come up with this function. So I tend to, if I don't know how to do it, I tend to play a game where I start trying some various months. So what would the average cost be if I had 1 month only? The $50 installation fee plus $42 a month. Okay, here, let's look at it this way. What's total cost going to be? What's the function for total cost? Can you still hear me? Because I'm not sure if you can or not. I'm getting a lot of static.
Yeah, I can. I said it was $93. I don't know if you heard that.
No, I did not. Okay.
Okay.
So the total cost is actually going to be 50 plus what? 43 times the number of months, right? Okay. Well, if this is our function for total cost, how are we going to get average cost? Average cost is going to be what? In terms of total cost. William?
Yes, I'm not sure.
Okay. If you take, when you're talking averages, and this refers to all kinds of averages, you take the total and you divide by how many there are. In other words, if I take my total cost and divide it by the number of months, I get my average monthly cost, right?
Okay.
When you used 1, you got a total cost of $93. Well, because it was only 1 month, that was your average cost also.
Okay.
But let's figure out total cost based on 2 months. Total cost based on 2 would be 86 plus 50, 136, but now there's 2 months. So the total cost would be 136, but the average cost would have dropped to 68. So just having it for 2 months, the average cost goes from 93 down to 68.
Okay.
But the key is the average cost is your total cost divided by the number of months. So this is the key, which makes this function 50 plus 43x all divided by x. Notice, very similar to your other problem.
Right.
And I had the variable in the numerator and the denominator. And they want to know the same thing, right? Graph it on your calculator and figure out when average cost is what? 58?
53.
Okay. So 53. So how are we going to do that in your calculator?
Graph the original equation.
Okay, so y sub 1 is going to be what?
50 plus 43x all over x.
You got to be really careful here. The one thing I do not like about the TI-84 is it does not tell you what you put in. And so it's real easy if you miss a parentheses or so to get this in there wrong.
Right.
In other words, you can't put in 50 plus 43x divided by x. You got to have
Parentheses over the
parentheses over that and then divide the whole thing by x.
Right.
Okay? And the easiest way to answer their question is to put in a y sub 2 of 53. And now wherever those two lines cross, you'll have your answer. And they might cross in multiple places. Although probably not. This looks hyperbolic in nature, which means it's not going to repeat. Which means it, in fact, is 1-to-1, which means this horizontal line can only cross it at one spot.
Right.
And it probably looks something similar to before, where you had that, and there's the y equals 53, and that's your... Okay? But the key on all these word problems is right here. Once you've defined your variable, exactly what it is, and like I said, 95% of the time, you can get that just by reading the last sentence. And in fact, most word problems, I start with the last sentence. I truly do.
Okay.
Give me a bunch of algebra word problems, and I'm going to start with the last sentence because that's where you begin. That's how you define your variable. You know, it doesn't matter if you're selling lemonade and Coke to, at a lemonade stand, or lemonade and iced tea, say. The last question will be how many lemonades and how many iced teas were sold. And when you define this variable, I believe 100% that you want to be as specific as possible. In this case, I could just say x equals the number of months. There's no misunderstanding that. But let's talk about my other case where I had lemonade. In lemonade and iced tea, well, x, is that the number of lemonade you sold or the price of the lemonade? Well, it's the number of lemonade. And so it's very important to be very specific when you define that variable. Because there are a lot of algebra problems that do involve items that are sold, and there's two variables associated with that item. There's the number that were sold, and there's the price that each was sold at. So you need to distinguish in the very beginning as to what you're looking for.
Okay.
Yeah.
A 3D printer builds up layers of
Tell you
materials.
what, don't even read the first sentence. Read the last sentence only.
Okay.
And then we'll go back, but I want to see if the last sentence allows me to define my variable.
This one has 3 little sub-questions, like an A, B, and C to it. So.
Oh, okay.
Should I?
Yeah, go back. Go ahead and read the whole thing. I'm sorry. Okay. I was trying to make a point, but this wasn't a good problem to make that point, perhaps.
A A 3D printer builds up layers of material to make three-dimensional models.
Okay.
Each posited layer bonds to the layer below it. A car company decides to make small display models of its vehicles using a 3D printer. The printer costs $24,000. The material for each model costs $300. So the first question is, write an equation that gives the average cost per model as a function of the number of models printed.
Exactly like the previous.
I'm sorry, what?
Exactly like the previous problem.
Yes.
What's my variable going to be?
The average cost. Or number of models.
Number of models, yes. Be careful. Price is rarely the variable.
Right.
Because they've given us these prices. And that's another important consideration when you're looking at word problems. Anything that they've given you, well, that's not going to be your variable. Okay?
Right.
Variable is what they're looking for. So I'm going to let x equal the number of models. What's your total cost?
24,000 plus 300x.
What's your average cost?
That all over x. The total cost over x.
Mm-hmm. And the question was what? When
Write an equation that gives the average cost per model as a function of the number of models printed.
Okay, you're saying models, right? Yeah.
Yes.
Yeah. Okay. I was hearing miles there for a moment. Talking
Sorry.
cars, I was thinking, oh, do I have this all backwards? So there's their answer, right? That must be answer to A.
Yes.
What's B?
Graph the function. Use the graph to estimate how many models must be printed for the average cost per model to fall to $700.
Again, that's y sub 1. Y sub 2 equals 700. And you would want to graph both of those, and that will give you the answer. That's going to take a lot of models, huh?
Yes.
Although there's only $300 per model, but that initial cost for that printer is significant. So you're going to have to print a lot of models. I'm guessing. In fact, I can do a rough approximation. We printed 80 models. That would cost $24,000. And then our average cost would be around $600. So a little bit less than 80 is going to be the answer.
Okay.
Just from doing it the rough way that I did. In other words, if I did 24,000 worth of models based on $300 per, well, I'm spending 24,000 fixed cost, 24,000 in variable cost. The average cost is going to be about double 300. Excuse me.
Okay. Bless you.
Oh, thank you. Okay, I think I'm done. Sneeze. So did you do it yet?
Yeah, I got 60.
Yeah, that makes sense. In other words, it's always a good idea if you have, not so much when you're graphing, but even when you're graphing, because you can always get this y sub 1 wrong. It's real easy to get that wrong, if you accidentally don't use parentheses or something. So
Right.
you don't want to be 100% dependent on that graph, the fact, whether you put it in there correct or not. So just follow my ballpark method here. In other words, if I'm going to spend $24,000 on models, then I will have spent exactly the same as my fixed cost, which means my average cost per model would be $600, correct?
Correct.
So 24,000 would be 80 models. 24,000 divided by 300. So therefore, since the average they want is 700, it would be something less than 80 models.
Right.
60 sounds perfect as an answer. In other words, had you gotten an answer of 90,
Right.
couldn't be that. Or 900, couldn't be that. Or 6, couldn't be that. It's always nice to know ballpark figures because you can frequently catch major mistakes when you're studying or when you're using ballpark figures.
Okay.
All right. What else do you have, William?
That worksheet's good then. It says, it says the Game Commission introduces 100 deer into newly acquired state game lands. The population N of the herd is given by N equals, on the numerator, 20 times the quantity of 5 plus 3t all over 1 plus 0.04t when t is greater than or equal to 0.
T is time, right?
Yes.
And it's number of months?
Years.
Years? Okay, so T is in years. And they started with 100, and N is the population?
Yes.
Okay. So if you let T be 0, N better be 100, right?
Right.
Is it?
I think so.
Yeah. The denominator becomes 1, the numerator becomes 100. So everything matches what they're saying. Now, what was their question again?
It says find the population when t is 5, 10, and 25 years.
Okay. So what we have is the population as a function of t. So what they're asking for is n of 5, n of 10, and n of 20. And if you don't understand what I mean here, say something, because this is important for any math student to know this notation.
Yeah, I understand.
This is like f of x, only it's n of t.
Right.
Okay? It's not n multiplied by t, it's n being the population, and it's a function of t, meaning I'm only going to find t's on the right side of this equation, nothing else. And then if I want to evaluate these various numbers at given t's, I write it like this. And what this means is that whatever's in the parentheses, you plug in for t.
Okay.
Okay? Now, did they say do this on a calculator or with a graph or?
It doesn't say, so I assume algebraically.
Okay. So I'm not sure if you know how to do it, but do you know how to put in a function and then evaluate it at various values? In other words, there's the hard way and the easy way. The hard way is just to go ahead and do the arithmetic. In other words, substitute 5 for t and figure out what that's equal to. And then go back and substitute 10 for t and then 20 for t. But that calculator has a feature on it where you can put in a function and then you can evaluate it at all those different values. I suppose an easy way to do it perhaps would be to put in a y sub 1, a y sub 2, 3, and 4.
Okay.
And y sub 1 would be this function. Y sub 2 would be y equals 5. Y sub 3 would be y equal 10. Y sub 4 would be y equal 20.
Okay.
And the intersection of all 3 points give you your answers to these 3 calculations.
Right.
Probably easier to do the math, because on that TI-84, finding intersections requires you to go left and right with the trace, and then it gives you the number. So it's a bit of a tedious operation. Not that the math isn't easy also, but there is another function on that. Here, let me pull out. I had a virtual. I have a TI-84, but battery died, and when I replaced the battery, I could never get it to boot up again. So, and then I started having most of my students use Inspires, so I got an Inspire instead of replacing the TI-84. But when I had my previous operating system, I found a free virtual TI-84 that I could bring up on my screen and show people which keys to hit. And actually, it was operational. It was pretty cool. I'd love to find that for an Inspire also. But I don't have that anymore, so I can't bring it up. But if you look at your TI-84 on the lower right, it says solve.
Yeah.
Well, that's where I'm trying to remember exactly how you do this, where you put in the function, and then you solve it for various values. In other words, you can put in 5 and it gives you an answer. You can put in 10 and it'll give you an answer, and so forth and so on, which would be the fastest way to do this by a lot.
Oh, yeah. Gosh, I don't remember how to do that.
You know, I don't either. However, let me give you the best tip I could ever give you. You want to know how to do something on a calculator? Go to YouTube. Suppose you didn't know how to do a linear regression. Go to YouTube, you type linear regression for the TI-84, and it'll show you a little quick 5-minute video for exactly how to do it.
Okay.
Okay? And that applies to any question you have about either of your calculators. If you don't know how to do something, the best place, I'm happy to help you with it if I know how to do it. It's been so long since I've done this particular thing on the TI-84 that I don't specifically remember how to do it, but you can certainly find out by going to YouTube. YouTube is a fantastic source for doing anything like that, because there's probably 100 videos out there that show you how to do that specific problem that you can choose from any of them.
Okay. I'll definitely have to look at that.
Yeah, that's definitely a good resource for you. Like I said, if we're in a session, I'm always happy to help you if I know how to do something on a calculator that you don't. But this particular case, I don't know the easiest way to do that. And it's hard for me to experiment because my calculator does not work.
Right.
But there are frequently times where you have a complicated function like this, where the math's not that easy to do, and you want to evaluate that function at a number of values, and that's when that feature for that calculator comes in really handy.
Okay. Is there a similar thing to do on the Inspire CX? I know you can...
I bet that calculator is so much better than the TI-84 that I'd be amazed if you couldn't. Again, on that one, I'm not sure I know how to do it, but I could at least experiment with that one.
Okay.
I don't want to do that while we're in a session, but yeah, you could. How long have you had your Inspire? Is that relatively new?
Yeah, just since the beginning of the school year.
Yeah. See, there's a big learning curve on that thing. It's so different than the TI-84.
Yeah, it is. It's
All your knowledge for the TI-84 is pretty much useless for the Inspire.
yeah,
The one thing that is key is that menu key on the Inspire.
yeah,
But even that, I've had mine for a couple years, but I don't use it that regularly. So it's easy for me to forget, and there's so much to know about it.
yeah. There's tons of different tricks. It's so much more of a computer than the TI-84.
Well, the one beauty of the Inspire is when you put in a function, it shows you what the function is. And
Right.
that's key. Not letting you make that mistake is key, because with that TI-84, it's really hard to put in some types of functions that are complicated.
Yeah. Okay.
What else you got today, William?
So for this same problem, it says what is the limiting size of the herd as time increases?
Ah, interesting. Okay. What your graph must look like is like a logistic curve. Let's talk about this for a moment. You have a couple of basic kinds of curves. Typically, populations grow exponentially like that,
Right.
but not continuously. In other words, they reach a point in time where the resources of the land don't let them keep growing exponentially, and they tend to flatten out like that. And so populations or even bacteria in a petri dish, bacteria at some point are going to reach the edges of the petri dish and you can't grow anymore. Okay? So there is a limit. You can kind of think of it as a horizontal asymptote on top and bottom. And this is the way these functions tend to look. And this is the way a graph of a real population would look. In other words, it grows exponentially for a period of time right in here, but then it levels off. Okay? So
Okay.
what you really want to know is what happens as t goes to infinity. That's time right there. This is n of t, the vertical curve. And so as t goes to infinity, what happens to this value? What does it approach? And your curve would tell you. Tell you what, do you have other problems after this, or is this the last one?
This is the last one on this page.
Well, let me put this into Wolfram Alpha,
Okay.
just so I can show you what I'm talking about with this logistic function. Now, let me look at that again. It's 20 times 5 plus 3. All divided by 20 times quantity, 5 plus 3t, parentheses, parentheses, all divided by t? No, the t.
1 plus 0.04 times t.
Okay. Now, notice how complicated that was to type in.
Yeah.
Now, if I hit enter, it's going to tell me what I typed in, which is a wonderful feature. I type it in correct. Was that correct?
Yes, yes, it is.
Okay. So, how come it's not drawing my curve? Ah, because I didn't use X.
Oh.
Hmm.
Do you have to set it equal to f of x, or?
No, man. I don't think so, but well, maybe. Maybe that was my mistake. I didn't set it, make it a function. Usually it graphs it, not graphing it. Why would it not graph that? Only graphing to the left of the y-axis. In other words, it's only graphing x's that are negative. That's bizarre. Let's see what else. The one other beauty of Wolfram Alpha is that it gives you the zeros, it gives you everything. You don't have to find anything.
Right.
But it normally gives you two graphs at different scales. You got to pay for it if you want the extra version. But
right.
Yeah, I don't know why it gave us such a strange looking graph, which means we can't really answer their question based on Wolfram Alpha's capabilities at this point. However, look at this alternate form down here. It's 1,500 minus 35,000 all over x plus 25. They're saying that's the same function we put in. Okay?
Okay.
Now, imagine x goes to infinity. What happens to that number, y? Look at the part on the right. What happens to 35,000 divided by infinity? That goes to 0.
Smaller.
Yeah, it keeps getting smaller and smaller and smaller. Eventually, it's going to try to go to 0.
Right.
Which means that the population that they're looking for is 1,500 is the answer.
Okay.
Okay? Because if they'd have drawn the curve the way I tried to draw my curve, like this, and that's what it is it's a logistic function. A logistic function, incidentally, is not one of your 10 basic elementary functions. You know, you've been taught all these basic functions and then all of the transformations of each, so that pretty much any function they threw at you was a transformation of one of those 10 elementary functions.
Right.
You know, y equal mx plus b, y equals square root of x, y equal x squared. These are all elementary functions. But the logistic function is not. It cannot be created by just transforming one of your 10 elementary functions. So in my book, they say, allow us to now introduce this new function called a logistic function. And it graphs a lot like this, with this lower horizontal asymptote and an upper horizontal asymptote. And the upper one is what the function approaches as t goes to positive infinity.
Okay.
And when they say t has to be greater than 0, it's because time is always positive. Time is never negative.
Right.
And that's all that means. But this level right there has to be 1,500 based on this alternate form of this function. They didn't plot it for us, which would have showed 1,500 as the line that it was approaching, but the fact that they give it to us in this alternate form allows us to figure out what the limit of y would be as x goes to infinity. Now, I understand you haven't had limits yet also, so this is a bit of a, that's why this is a graphical problem, because you don't really have a good way of solving it algebraically. Whereas if you graph it, you'll see that upper horizontal asymptote. And clearly that's what it would approach, and that thing's going to be y equals 1,500.
Okay.
Okay? Because this doesn't change. The 1,500 doesn't change as x gets big.
Right.
But this part here gets smaller and smaller and smaller and smaller as x gets big. And it doesn't ever reach 0, just like this function never reaches that horizontal asymptote. But nonetheless, it's still approaching it. You're taking algebra trig, right?
Precalc/trig.
Precalc
Yeah.
trig. Okay. All right. Yeah, I was going to say this is definitely precalc. That logistic function doesn't usually get introduced until you get to precalc.
Yeah.
And then your trig is next semester?
I believe so, yes.
So you probably don't have too much new material that they're going to introduce you. You only have like 3 weeks before you're going to end up taking your semester final, right?
Yeah, I think so.
Okay. So yeah,
crazy.
they may be introducing a little more material, but I would think the last couple of weeks of that they'll just be reviewing.
Yeah, I should hope so.
Yeah, really. And in fact, the sooner you get that review material, you should send it to me.
Okay. Send you pictures of it, or?
Yeah, well, that's the best way. Yeah, just take a picture with your cell phone and send it to my email address. And then I can bring it up on the screen. Even these word problems today, that would have probably been a little easier to do.
Yeah.
Uh,
I apologize.
No problem. No, I was just saying that word problems, there's so many sentences in it, but by the time somebody's read it to me, I've forgotten what sentence 2 was. So it's easier to send those as pictures also.
Okay.
All right. Well, William, I will let you go and talk to you next time.
Okay, great. Thank you very much, Mr. Cowan.
All right. Bye-bye.
Bye. Have a good weekend.
You too.